So in sort of like examples so far, we've always assumed the electrons are shared equally between my two covalently bonded molecules. So, but that's not always the case. So if I sort of like do HCl, HCl looks like that, and we would assume that this pair is a shared pair of electrons between your H and Cl. However, that's not the case. The electrons actually spend more of their time on chlorine because chlorine's got a higher electronegativity. Electronegativity is just the ability of an atom that's in a covalent bond to attract the electrons to itself. So if I was to draw, I could draw it like that, and H has a little plus charge, and chlorine has a little negative charge. So if we put it delta plus and delta minus. If I took it to the extreme, I would have a purely ionic substance, like so. So it's somewhere in the middle between purely ionic and purely covalent. And most things like that, the only really purely covalent things that you get are going to be where you've got the same atom combined with each other, because they're going to have the same electronegativity. If you look in your periodic table, the most electronegative atom is fluorine. So fluorine is there, and it increases across a period and then up a group as well. So fluorine is there. So the key ones to watch out for: fluorine, chlorine, oxygen, and nitrogen are the ones that really do kick out.
Why, if I know electronegativity goes like that, so that
at
the top, but why is neon?
Neon, because neon doesn't bond. Neon's
so
a noble gas.
The noble gases you just ignore.
Yeah, just ignore them. Yeah, noble gases don't do anything. Yeah. So it's really important because that gives me a little charge on my molecule. So the way you do it now, that gives me a polar molecule. If I look at that molecule overall, it's got a little charge across it. So I've got a polar bond and I've got a polar molecule. But I can have polar bonds and non-polar molecules. So let's think about carbon dioxide. Carbon dioxide looks like oxygen is very electronegative.
So we'll have the minus.
So delta minus, delta minus, delta plus. But if you look at the molecule as a whole, I've got a negative bit there, a positive bit and a negative. I've got two negatives on opposite sides of each other. So overall, if I look at the molecule as a whole, it's cancelled out. So I've got polar bonds, but a non-polar molecule. Now, it's because you would say that this is a symmetrical molecule. So if they ask you to explain why, always try and say it's because that's a symmetrical molecule and that's an unsymmetrical molecule.
So you say like symmetrical molecule cancel charges out?
Yeah, that's right. Yeah. That's an unsymmetrical. The other symmetrical is something like carbon tetrachloride. Tetrahedral, like so. So chlorine really electronegative. So delta minus, delta minus, delta minus, delta minus, delta plus. So if you try and think minus plus minus. So again you've got two minuses on the opposite side of the plus. So I've got polar bonds, but a non-polar molecule. Like so. And it's really important you can do that, so when we look at intermolecular forces, which is the next little bit, you're happy with polarity?
Yeah.